Okay, surface area of a cone. All right, so we've talked about surface area before. We know that the surface area of a three-dimensional figure is the area of its faces added to the area of its base. More than one base, of course, if it's a prism or a cylinder. But here we're going to be talking about a cone. So we know it has a circle on one side and then a point on the other. And the interesting part about this is because the face, it's really only one face, and it wraps around the shape. So we can't really use, as we have for prisms and really cylinders as well, the area of a rectangle or a triangle to help us. We have to use as with a pyramid, for example, we have to use really this understanding of lateral area as 1/2 perimeter times the slant height. The slant height, of course, being the diagonal distance from the outside of our base up to the point, right? And so what we know for a circle, our perimeter is not called perimeter, it is called circumference. And we know that circumference of a circle has a couple different formulas, but I'm going to use the one we're probably more familiar with is 2 pi r. So 2 times the radius times pi. Of course, the other one is pi d, and they mean the same thing. We know d, the diameter, is equal to 2 times the radius. The reason I'm using this formula is because of this. We know that 1/2 times 2 would cancel each other and become 1. And so that gives us our formula for the lateral area, the lateral area of our cone, pi r times L. So you really should, if given the diameter, figure out what the radius is first before doing the calculation. So then surface area, of course, is our lateral area plus the area of our base. And so in this example, we know our base is a circle, pi r squared is its area. And so, of course, depending on how you've seen this, you certainly could do what I tend to do, which is find our base area and our lateral area separately and add the two together afterwards, or you could use this formula, which I've just written on the bottom of our screen here, which just says, plug in R, plug in L, and work the calculation all at once. All right, so let's do an example. So we have a cone here, and we have a radius of 2 inches. And we know that we need to know L, and we need to know our base area. Let's say we have a height of 5. So that is the vertical height of the figure. So the distance from the center of our base up to the point. And we need to know what L is. And we should see that this little cross section here forms a right triangle. So we have the right triangle with sides 2 and 5 and L. So we need to figure out what the slant height is. So we have to do L squared equals 2 squared plus 5 squared. So L squared would be equal to 29, 2 squared being 4, 5 squared being 25. And then the square root of each side to figure out what L is. And that comes out to about 5.385, so about 5.39. Square root of 29 cannot be written in simplified radical form. 29 is a prime number. Okay, so then we have L is now 5.39. And then our base area, we know that we are looking at a circle here, so it's pi r, which is 2, squared. 4 pi would be the exact area, 2 squared being 4, of course. And 4 pi comes out to 12.566, so 12.57 for capital B, our base area. And then we know lateral area, I'm going to do this separately. Lateral area is pi RL, so pi, radius is 2, L is the 5.39 that we found using the Pythagorean theorem. So pi times 2 times 5.39 is 33.866, so 33.87 for our lateral area. And then, of course, our surface area is lateral area plus base area. And again, remembering that we have the two separate. We could also find them together if we were just to use that other formula, just basically doing pi r L plus pi r squared at once. Inches squared, of course. All right. So I would like to go over this one. What if I have a diameter? I know that I have R, L, and capital B that I need to find. And so I need to know that D is 2R, so 12. The diameter is 2R, remembering that diameter is a segment that goes from one side, one end, one outside edge, however you look at it, of a circle to the other through the center. So I do 12 over 2, which is 6 for R. L, I'll give it to us in this one. Let's say that we have L is 10. And so base area is pi r squared, which would be pi 6 squared, 36 pi, or 113.097, so 113.1. Lateral area is pi times r, which is 6, times L, which is 10, which is 60 pi, or 188.495, so let's just use 0.5. And then surface area is 188.5, oops, not 18.5, 188.5 plus 113.1, and then 188.5 plus 113.1 is 301.6 meters squared for our surface area. Alright, so I'll give you guys a second. You guys hit pause and try this one yourself. I am going to give you two pieces of information though first. I will give you the slant height in each. Let's use 4 inches here and 11 meters here. Alright, so here are our answers. For the first cone on the left, we had a radius of 3. If our diameter is 6 inches, our radius is 3 inches. And I gave you the slant height of 4 inches for L. So base is pi r squared, so 3 squared or 9 pi, which is 28.27. Lateral area is pi r L, so pi times radius of 3 times L, which is 4, equals 12 pi, or 37.70. Add the two together for surface area of 65.97 inches squared. And then for the second one, I gave you the radius, which was 8, and the slant height, which was 11. So you have 8 squared pi, or 64 pi, which is 201.06. And then for the lateral area, you have pi RL, 88 pi, 8 times 11 times pi, which is 276.46. Add the two together for your total surface area, 477.52 meters squared.